So this third question asks us to show that the perimeter of the ellipse x equals a sine t and y equals b cosine t, where a is larger than b, larger than 0, is L equals 4a, the integral from 0 to pi over 2, of 1 minus e squared sine squared t all to the square root dt, where e is the eccentricity of the ellipse is equal to c over a, and c is square root of a squared minus b squared. So this is quite a long formula, but we can always start from what we know. So if I'm to graph this ellipse, it's going to look like this. Here I have a and negative a, b and negative b, so it will roughly look like this. So notice that the perimeter is made up of these four parts. So part 1, let me change another color. So part 1, part 2, part 3, and part 4, right? So since the ellipse is, this is regular and it's symmetric across the y and x axes, so it suffices to find the length of one of the parts, let's say this first part, and multiply by 4, right? So the perimeter of the ellipse is 4 times this blue part. Great. So how do I find the length of this blue part? So recall, we have the arc length formula. L, which is the arc length, is equal to the integral of dx dt squared plus dy dt squared, and everything square root dt. So applied to our scenario, what is this? So we have the blue part 1 is equal to the integral from 0 to pi over 2, because at this point I'm at t equals 0, and at this point I'm at t equals pi over 2. So these are going to be the bounds of my integration. So my blue part 1 is equal to integral from 0 to pi over 2 of what is dx dt. So is going to be a times cosine of t, right? Because the derivative of a sine t is a cosine of t, and dy dt is going to be negative b times sine t. So I plug these two in, I get a squared cosine squared t plus b squared sine squared t. Everything square root dt. Great. But how do I make this formula look like this? Right, I want to show that it looks like this. So recall we have the original formula L equals 4a 0 to pi over 2 1 minus e squared sine squared t square root dt. So I want to plug in e equals a squared minus b squared square root over a. This is what we're given. Then I obtain that this is equal to 4a times the integral of 1 minus a squared minus b squared over a squared sine squared t square root dt. So what I can do now is I can pull this a inside, right? Because integral is linear. I can pull any constant inside or outside. So this is 4 times, but if I can pull it inside, I can also pull it inside the square root with the cost of squaring it as well. So this is going to be a squared minus a squared minus b squared sine squared t to the 1/2 dt. So now let's open the parentheses. So this is going to be a squared minus a squared sine squared t plus b squared sine squared t to the 1/2 dt. Then I can combine these two terms, right? I can factor out the a squared. So I get a squared 1 minus sine squared t plus b squared sine squared t to the 1/2 dt. But what is 1 minus sine squared t? We recognize this as cosine squared t, right? So this is going to be 4 times integral a squared cosine squared t plus b squared sine squared t, all to the 1/2 dt. But what is this? This is exactly what we obtained by the arc length formula. And we have a 4 multiplied in the front. So this is going to be 4 times the length of 1. Right, so it's 4 times this length. And so this is going to be equal to the perimeter of ellipse.